Welcome to Educator.com. Today's lesson introduces the concept of matrices. And matrices are used throughout math and science as an approach to problem solving. In this course, we're going to use them to solve systems of equations. However, they're also used in fields such as physics, computers, and genetics. First of all, defining what a matrix is. Well, a matrix is a rectangular array containing variables or constants, which is enclosed by brackets. And the plural form of the word matrix, which I just used, is matrices. So you'll hear me say that in the course. And to give you an example of what a matrix looks like, as I said, a matrix is enclosed in brackets, and it contains variables or constants. And starting out, we're going to be working with matrices that contain constants. And then towards the end of this series of lectures, we'll see a matrix that involves variables. So this is an example of a matrix. And these are usually designated by capital letters. So I could call this matrix A. Another matrix, B, might be smaller, perhaps containing only two numbers. Another matrix C could have a different set of numbers. Each variable or constant within a matrix is called an element. So 2 is an element, 1 is an element, each of these is an element. And later on we'll also see matrix equations, because you can perform operations with matrices. For example, I could have a matrix equation that says A plus B equals C. So I could have some matrix A that when added to B equals another matrix C. So just as we performed operations on constants and terms, we can perform operations on matrices. Okay, starting out, it's important to understand the concept of dimensions when referring to a matrix. And with a matrix, dimensions refers to the number of rows and columns in the matrix. For example, let's say I have a matrix. And you can see, of course, that it has a certain number of rows and a certain number of columns. Well, M refers to the rows, the number of rows, and here that's 1, 2, 3, 4. I have 4 rows. For this matrix, looking at columns, and we say N here is the number of columns, and I have 1, 2 columns. Therefore, I would call this, the dimensions of this matrix, 4 by 2. This is a 4 by 2 matrix. And this is important because the dimensions often limit what you're able to do, which operations you can perform on a set of matrices. So, looking at another matrix, this matrix has 2 rows and 1, 2, 3, 4 columns. So this is a 2 by 4 matrix. So it's important, the order of the numbers is very important. Here it's 4 by 2, 4 rows, 2 columns. Here it's 2 by 4 because 2 rows, 4 columns. Okay, there are certain matrices that are special cases. A 1 by n matrix has 1 row and is called a row matrix. For example, this is a row matrix because it has 1 row. So that this first term here, it tells the number of rows. And looking at the number of columns, I have 1, 2, 3, 4, 5, 6. This is a 1 by 6 matrix, and it is a row matrix because it has only 1 row. A second type of special matrix is a column matrix. Here, it's an m by 1 matrix. It has one column. So here one row, here one column. For example, make this a little bit more spread out. 2, 3, 8, 4, 2. Okay. So here I have 1, 2, 3, 4, 5 rows. I have 5 rows, but I have only one column. So this would be a 5 by 1 matrix, and since it has a 1 right here, this is a column matrix. A third type of special matrix is called a zero matrix, and this zero matrix has all its elements equal to 0. For example, this would be an example of a zero matrix. So 3 special types of matrices: a row matrix with 1 row, a column matrix that has 1 column, and a zero matrix which contains elements that are all 0. We say that 2 matrices are equal if they have the same dimensions and their corresponding elements are equal. So let's talk about what corresponding elements are, using this matrix, this set of matrices as an example. Okay, so I'm going to call this A and this matrix B. And I can say that A equals B because the corresponding elements of A and B are equal. Elements are corresponding if they have the same position within a matrix. By position, I mean the same row number and the same column number. So right here, this element is in row 2, column 1. Its corresponding element is also going to be in row 2, column 1. And these are the same. And my row 1, column 1 elements are the same, and so on. For each position, all of the elements are the same, the corresponding elements. Therefore, these 2 matrices are equal. If I had the same numbers, but they weren't in the same positions, they would not be equal. The 2 matrices would not be equal. So same dimensions, and I do have the same dimensions. 1, 2, 3 rows, 2 columns. This is a 3 by 2 matrix. Same here, 1, 2, 3 by 2 matrix. Same dimensions, and corresponding elements are all equal. 1 equals 1, 3 equals 3, and so on. So I can say that these 2 matrices are equal. Okay, doing some examples. First, we're asked, what are the dimensions of this matrix? And remember that when we do dimensions, we say m times n. So we look first at the rows, number of rows, times the number of columns. So all I need to do is count the number of rows. That's 1, 2. So m equals 2, and that's the number of rows. And columns, n equals 1, 2, 3. There are 3 columns. Therefore, this is a 2 by 3 matrix. The dimensions of this matrix are 2 by 3, rows by columns. Example 2, different matrix here. What are the dimensions of this matrix? Again, we're looking at rows by columns. I have 1, 2 rows, 1, 2, 3, 4, 5 columns. So this is a 2 by 5 matrix because it contains 2 rows and 5 columns. So always rows first, then columns. Write the 3 by 3 zero matrix. Well, this is telling me that I'm going to have 3 rows and 3 columns. And since it's a zero matrix, all elements are 0. Okay, so it's going to give me 1, 2, 3 columns and 1, 2, 3 rows. So I just need to fill in, and all elements are 0. And again, a matrix is contained within brackets. So this is a 3 by 3 matrix, 3 rows, 3 columns. It's a 0 matrix, and I have my brackets around it to indicate that it is a matrix. This is a 3 by 3 0 matrix. Example 4. Write a matrix that is both a row matrix and a column matrix. Recall that a row matrix has 1 row and then some number of columns. A column matrix has some number of rows, but only 1 column. Putting this together, this is telling me that I'm going to have, if it's both a row and a column matrix, that means that this M position, the rows are going to be 1, and the columns are also going to be 1. So this is a 1 by 1 matrix that they're asking for. And I could use any constant or variable. This would be both a row matrix and a column matrix. It has 1 row and it has 1 column. Or it could be 5. Or I could use a variable such as y or x. So any of these examples would be a row matrix or a column and a column matrix at the same time. That concludes this lesson from educator.com, and I'll see you next time when we talk more about matrices.